The standard form of a linear DE is the following. So it's dy dx. Oh, these aren't even my notes. plus p of xy, I don't need them, I think, equals f of x. That's called the standard form, okay, of a linear DE. Okay, so basically, if you have something like, x squared dy dx plus some stuff, what do you have to do to put it in standard form? What do you have to do? What do you have to divide by? X squared. So you have to divide by x squared here. So basically, you got to make this a 1, right? So this has to be a 1, okay? That's basically what I mean by standard. So just make that a 1. So, okay. So let me give you the steps, like step 1, step 2, step 3, and then we're done. We're just going to do problems. That's the nice thing about this class. It's like, here's the concept, and this is how you do it. And then you just do it. So steps. So 1. First step is to put it in standard form, okay? That's the most important step. So write, not the most important, but the first step. Write in standard form. Write in standard form. Step 2. I'm thinking, I don't have, my notes are over there. I'm gonna wing it. Compute mu of x equals e to the integral of big P. Say, what is that? So, I don't know if, can you all see that? E to the integral of big P? I'm going to write it again. I'll write it down here.
Are you going to write more things underneath the standard form?
No.
Okay.
You're worried about space?
Yeah, I just want to know if I should decide.
No, you're good. So compute mu of x. This has a name. By the way, this is the letter mu. Maybe you've never seen it. Has anyone here never seen the letter mu? You've seen it before? Oh, you've seen it? Oh, okay. Well, if you've never seen it, it's spelled, yeah, mu, right? Because it looks like an M. It also looks like a U. So it's mu. I don't know if that's true. It's a real Greek letter. Sometimes I'll do this, or like this. But when it's typed, it's like a fat, elegant mu. It's like, this has a name. This is called the integrating factor. So integrating factor. So integrating factor. Okay, it's called your integrating factor. All right. Step 3. Multiply your entire DE by mu of x. So multiply the DE by mu of x. By mu of x. So multiply the DE by mu of x. By the DE, we mean the one in standard form, right? So multiply by mu of x. That's step 3. Step 4. Step 4 is the hardest step, right? Just finish. So I'll just show you. It's so hard that writing it down would be harder than actually doing one. So let me. I'll write some stuff as we do one. I guess I can just do any problems. It doesn't really matter. Yeah, maybe we'll start with. Yeah.
So the job of the integrating factor is to dissolve the derivative of this product?
No.
Of the terms.
No, good question. I'll tell you actually. So, because no one's ever asked. So the job of the integrating factor, so why are we doing this? I'll just tell you because this is really deep and it's important. When you do this, I'll just tell you how to finish. When you multiply by mu of x, this whole thing, okay, will always become, so like if I put a mu of x here, and if I put a mu here, and I put a mu here, this whole thing will become d dx of mu of x times y. every single time. It will magically become this, always. You'll see when we do an example. And then what you'll do is you'll just integrate both sides and you'll finish. But it'll magically become this via the product rule, right? But let's go ahead and do an example. So, 'cause I can't explain it here because, I mean, I can, but it's a little more abstract. But it does work, right? So after you do this, the whole left-hand side of your DE magically will become this. So you just memorize this. You just write down ddx, mu of x, y, every single time. And you can check your work in the problem, because you'll be able to check this and you'll get this. So I'll show you. That's the key step. If you understand, once you understand that step, you're ready for the test. So let's do I think it was number 5, 4. Can we read number 4? Because my notes are different. Yeah, it's good.
Number 4 off the home.
Yeah, do you have it?
Yeah, so it's x times dy dx minus y is equal to x squared sine of x.
Beautiful. Thank you. Thank you, Nick. Yeah, nice problem. I did number 3 in my other class, and I was like, I don't want to do the same one. It's way more fun when I do a different problem. Like, yeah, it's like more exciting. These are all about the same level of difficulty. Some of them are a little bit harder, but like 2-2 I think has harder questions. This should have multiple questions. It wants the answer, it wants something called the transient terms, and it wants something called the interval of definition. On your test, I will only have you solve these, but we'll go over the other stuff as well. All right, solution. So the first step is to write in standard form. How can we do that? What do we do? Divide by x. Yeah, divide by x. So divide by x, divide by x, divide by x. So we have dy dx, right, dividing by x minus 1 over xy equals, divide by x, that gives us x sine x. So we're there. The thing is always following me. Unfortunately, it's necessary. Like I tried to record it, like I said in my Monday night class, and it just. Now we have to compute this thing, this integrating factor. So big P here is negative 1 over x. That's the big P. So we have to compute mu of x. So mu of x equals e to the integral of big P. So negative 1 over x dx.
So big P is always going to be the second.
Yeah, whatever's here.
Okay.
Yeah, thank you, Rafael, because I didn't say that. Yeah, big P is always whatever is here, okay? Always. Hey, Luigi, you're back. All right. So I'll go over it again. Don't worry. So step 1, you have to make sure this is in standard form, so you divide by x. Step 2, as like Rafael said, this is always your big P, right? And you always compute e to the integral of this. This is really useful, by the way. When we do the Bernoulli differential equations next time, the Bernoullis, they're going to become linear. So
And so you bring the sign along with it.
yes, you bring the sign along with it. And the negative sign is going to make it a little bit harder, which is kind of nice. So this is equal to e to the negative ln absolute value of x. We're going to simplify it and show all the steps, right? Because 1 over x is ln absolute value of x. And the negative hangs out. All right. We need to get rid of this, but we can't yet because the negative. You want to think about it like this. And then what you can do with the negative 1 is bring it up and write it like this. That's called the power rule for logs. Remember, the multiplication turns into exponentiation. That's bad. Just goes up. It's too much. That one's not cool. So this is e to the ln x to the negative 1. So now the e and the ln, they cancel. So this will be absolute value 1 over x, right? Because that's x to the negative 1, right? I rewrote it that way. I skipped a step. Okay, there. So here's the key step. So if you have the absolute value of x, that's equal to x if x is greater than or equal to 0, and it's equal to minus x if x is less than 0. Okay. So we have to somehow get rid of this. So how do we do that? Well, we do whatever we want, right? So we could use negative. We could write negative 1 over x. Let's say we did. I'm not going to. I'm going to erase it. Let's say we chose this one. Let's say we pretend it's less than 0 when we do this. If we do this, then we can multiply by negative 1 over x in the next step. But then we can divide by negative 1. And so it's like multiplying by 1 over x. So it doesn't really matter which one we choose. So I like to choose the easy one, or the easier one. So I always pretend it's positive. So I'm going to say that here. This is if x is positive. Right? 1 over x is positive if x is positive. This is extremely important for the homework. The homework will ask you for something called the interval of definition. This is where it comes from most of the time. On a test, I will not ask for that because in the homework, a lot of times it's multiple choice, which makes it easier. The test is not multiple choice, so I don't think it's fair to put that on the tests, whereas, yeah, don't worry about it.
Can you explain that last part again?
This?
Yeah, all of that.
Yeah. So basically we have a choice. We can put 1 over x or negative 1 over x. In any case, we have to multiply the whole thing by 1 over x. So if I put a negative 1 over x, I can multiply the whole thing by negative 1 over x, but then I can divide by negative 1. So it's like I multiplied by 1 over x. So no matter what, it's the same. So it doesn't matter which one you pick. So I always just take the positive one, and I always just make sure this is positive. This will be positive whenever x is positive. And this, so just always make it positive, and then just make this positive. This will give you the interval of definition in the homework. Yeah?
Unless it's an IVP involving a negative x, then we should probably use the negative x value.
If it's an IVP, oh, that's pretty deep. If it's an IVP, just pretend it's, yeah, okay, so like let's say it's an IVP, and it's like y of negative 4 equals 2, then yeah, make x negative. But I don't think it's going to come up. That's pretty deep. Good, I know, yeah. Yeah.
So I understand everything except for when you multiply by mu. What happens to the rest of the stuff?
This? This?
One more.
This?
One more.
This?
Yeah, what happens there?
This is just the formula. It's just this. We're just working it out.
How do we get there from the last step?
From here to here?
Yeah.
Oh, we're just following the steps. Step 1 was this. Step 2 is this. Yeah. Now we're going to do step 3. Yeah, this is just the steps. So this, yeah, we're just following the steps. So, all right. So now step 3. Okay. Yeah, no, I spent a lot of time on that step. Step 3. Step 3 is to multiply by mu of x. So let's do that now. We haven't done it yet. Let's do it. Yeah, thank you. Thank you. Let's do it. Let's do it. So we're multiplying the whole dE by 1 over x, okay? So it's 1 over x dy dx, right? See how we did that? And then this will become negative 1 over what? X squared. Oh, good, Nick. You got this. Y equals, what's left on the right-hand side now? Sine x. Sine x, very good. Sine x. Let me pause here. I'm going to just take a moment to pause, make sure you got this. The next step is super important because there's no more steps. Step 4 is finish. Right? So like now you really have to get it. So you go home. The notes just say finish. Ah, screw this. Like no, this one? Ah, so it's 1 over x. Yep. And then when negative 1 over x squared, and then this one cancels, right? So. It's really hot in here. Is it hot in here or is it just me? It's hot? It's me? You're all right? Any questions? Any questions on this one? It's all right.
Any reason you put the y in the... Maybe I'm just being dumb.
No, it's okay.
In the final, in the finish,
Yeah.
you put a y instead of top of the fraction, just put it to the side.
Here?
Yeah.
It's already here. I'm just multiplying this by 1 over x. 1 over x. 1 over x.
It's not on top.
Yeah, that's what
Or is it just?
It can be on top. I just didn't want, oh, like why don't I do y over 1 over x squared?
Yeah.
No, because I want to explain the next step. That's why.
Okay.
Foresight. Yep. I want to, don't put it up top. It'll make it harder to understand.
Oh.
Yeah. You'll see. Because watch. So now this is always going to be, this is the key step here. Every once in a while, some people don't understand this step. And they try to like find shortcuts for it. Try not to do that. Try to understand it. once you understand it, you'll get it right. So this is just this. And this, what is this? Well, it's just like I said over here, I think, because Anna asked, right? It's mu times y, right? So mu, I already forgot. What was mu in this problem?
1 over x.
Oh yeah, 1 over x. And then it's times y. So this should be this. We're going to check in a minute. Let's check. The derivative of 1 over x is negative 1 over x squared. You could do that, right? I mean, you could memorize it. I remember the day I memorized this. I actually remember the moment in my life when I memorized this derivative, right? So the derivative of 1 over x is negative 1 over x squared. So let's use, oh, the product rule. Do you all know the product rule? Oh, let me remind you. So look, so it's the derivative of the first times the second plus the first times the derivative of the second. So this is the first and second. Derivative of the first times the second plus the first derivative of the second. So check it out. The derivative of the first times the second plus the first times the derivative of the second. Boom, it's correct. Right? Every single time, right?
Do you have a partial derivative?
No, we're just doing a product rule.
Okay.
So the derivative of the first is this, times the second piece is this, plus the first piece is this, times the derivative of the second piece is that. You see it, the product rule? Do you see it, Rafael? Do you see it? You don't see it, Rafael? Do you know the product rule? Do you know it?
Yes.
Let me do it again. Let me do it again, Rafael. Look, look. Okay, look, Rafael. Look, look. It's the derivative of the first. It's okay, be honest. Derivative of the first times the second plus the first times the derivative of the second, right? The derivative of 1 over x is this piece.
Okay.
You just have to know that. So that's memorized. And then times the second piece plus the first piece times the derivative of the second piece. What don't you see? You don't see it?
If you didn't see, couldn't you just look at the bottom one there and use the product rule off of that?
Yeah, like this. Yes, I'm about to do. Good idea. So you can just do it. Watch, watch, watch. The derivative of the first times the second plus the first times the derivative of the second. Now it's in order like Emily said because she's smart. Derivative of the first times the second plus the first. Look, it's exactly the same thing. You see it now?
Yeah, I got it.
Yes! Good, no, good. Everyone see it? This is like the hardest part for people because if you don't get it, 10 other people don't. Well, maybe not 10, but at least 6. So right. This is one of those things like I'll do it and then like next week people are like, oh, I don't get it. It's hard. So again, derivative of the first times the second plus the first. And it's always this, okay? Always. The only time it'll change if it's not y here, like if it's an r, then you put an r here, right? That's the only thing, right? But it's always mu times y, mu times y. We're going to do another one after this. How do you get rid of a derivative? What's the opposite of differentiation? Integration. So don't put the integral sign. Don't do this because then you'll forget the dx and there's no room. So just write integrate. And then just do it in your head. Right? Because this goes away. Right? This goes away. Uh-oh, we got to integrate sign. Let's not mess up here. Is it cosine or negative cosine? Negative cosine. I'm starting to sweat. Plus, let's mess up there, right? Plus c. Plus c. Plus c. And then to finish solving, we just multiply by x. So it'd be negative x cosine x plus c. We're definitely going to do another one after this, for sure. Usually it takes a couple of these until you start to get it, right? This is particularly tricky here. This is the finish part. So that's one of the answers in the homework. On a test, that's all you would have to do. Okay.
I'm sorry.
Yes?
You say not to put the integrate symbol?
Why did I say not to do it?
Yeah.
Oh, because check it out. This is a common mistake. And then you have to put the dx. That's all, because there's no room for the dx.
Okay.
But there's never any room, right? You see it? Yeah, yeah. People, yeah, because you could do it, but yeah. It's just people always forget the dx. So as a habit, I never do it. Good question. Yeah.
If you forget the dx, is that you just wrong?
If forget the what?
If you forget the dx, if you don't put it.
Oh yeah, it's bad. That's a bad mistake. Yeah, it's like minus a couple points. Yeah.
So just never write any integral.
Yeah, it's better to just, oh, if you forget the dx, you mean?
Just skip the integration.
Oh, you mean if you do this and forget the dx?
Yeah.
Oh, -1. Yeah, but you won't. If I notice it, right? I'll be honest, when I grade, I grade really fast. So I look at it, if the answer's right and there's some work, I just mark it right. Like, if there's a, but if the answer's wrong, then you get, oh, what's going on here? Like, is there any hope for partial credit, right? So, just don't get it wrong and show work, right? Okay. The interval of definition is the largest interval over which we have the solution. So first of all, notice that x can't be 0 because we divided by x here, right? So x can't be 0 because we divided by x. And right here, this step here, this is where it comes from, okay? So it's going to be 0 to infinity. That's going to be your interval of definition right here. If we would have picked x to be negative, it would be negative infinity to 0. But we didn't, so it's this one. It's multiple choice in the homework usually, so that's that one, right? So usually comes from here, okay? Usually comes from here. It's for the homework only for the homework, okay? The homework wants transient terms. There are no transient terms. I'll explain what those are in a minute. So no transient terms. So what's a transient term? A transient term, oh, I messed up. There's an x here. No one got that. It's on video too, huh?
I was wondering why I was wrong in the homework. I was trying to find it before you did. But I didn't, so.
Is that a point? Well, I messed up, but no one got it, so.
You should get everyone should get it.
Everyone should get a plan.
You really think so? Oh, come on. All right, fine. All right, that's fine. It's really bad. I shouldn't have said anything. Well, that'd be really bad. Huh? Yeah, I don't have any pen. I don't have a pen.
I'll give you a pen.
Deduction. I'm kidding. I'm kidding. It's like, deduction. I don't have any paper. No, I have paper. What class is this? DE? Wednesday night. Yeah, I have a bunch of folders. This is us. Oh, Matthew Fisher, you're here. Okay, that fix. Our whole class gets a nice pen. It's very light. It was like arrow, like, it's like, is that on purpose to be that light? Like, yeah, it's like, whoa. All right. So transient terms are terms that are eventually 0. So if you had like 2 over x, when x goes to infinity, that's 0. So that would be a transient term, right? So here, when x goes to infinity, nothing goes to 0. So there's no transient term. So you just let x go to infinity, and if you get 0, it's a transient term. But there are none. So like, let's say the answer was y equals x squared plus 3 over x plus c over x squared. Say it was that, right? In this case, 3 over x is a transient term because it goes to 0. What's the other transient term in this case? C over x squared. Very good, Anna. C over x squared.
X approaches infinity, it gets closer and closer to 0.
Very good. It gets closer and closer to 0, right? This one approaches infinity, right? So these would be the transient terms. It's not on the test or anything, but it's in the homework. So transient terms, you take the limit. If you get 0, it's a transient term, right? This was a bad example in that regard, but it was a very good example because we had this negative here that made it harder, right? Also, yeah, it was just a decent example. Yes, Nick?
You said you weren't going to ask us about the
Interval.
yes, okay.
Correct. Right. On the test, it's just the answer. You don't need this. Was this multiple choice, Nick, in the homework?
No, there's actually blanks for it.
Weird. Okay. Weird. Yeah. So I will not ask you for the interval or the transient terms on the test. No way. All right. Let's do another one. I think there's one that's pretty uncomfortable, and I think it's the one with a bunch of trig functions. There's one with secant and cosecant, but I don't want to. I guess we could, yeah, let's do that one. That's really bad. No. Let's do 7. Let's do number 7, I think. 7 might be, 7 is good. 7. Anyone have 7 up? Not the drink, 7 up. Let's get it?
Yeah, it's
Oh. It's caffeine.
sine x times dy of x
Uh-huh.
plus sine x, and that's in parentheses actually, times y equals 1.
Equals 1. Thank you. Perfect. Very good. So this is our DE, right? This is a good test question also, right? Really nice problem. There's usually one of these on the final. Every semester you'll have one linear. yeah, on your final. So the final is heavily from the first exam because I use it to replace the lowest score. And the lowest score is always pretty much this test. This is the hardest test. I mean, if you get an A in this test, you can get an A in the class. For sure. Like this is hard, right? It gets easier after this. And it's completely different. So what's the first step in this case? What do we divide everything by in this case? Cosine x. Yeah, good. Got this. So divide by cosine. So divide by cosine, divide by cosine, divide by cosine. I remember looking up sine and cosine on the internet before I knew what they were. That was an experience. I read it as sin x. I'm like, what is that? Like, since? Since. Plus. I don't get it. Sine over cosine. What's that? 10? 10x. Y, a secant x. Yeah. Secant x. I don't get it, Rafael. Since? It doesn't matter. Sinks. Oh, sinks. Cusks. Yeah, that's really bad. Oh, no. Yeah.
I was going to say that the X looks very sacrilegious if you kind of think about it in like a sin perspective.
All right.
I don't know.
So now we have to compute the mu thing. What's the mu thing called? Do you remember that has a name? The what? The integrating factor. Yes, very good. So mu of x is equal to e to the integral of tangent of x. This is a nice integral because if you have a calculator that does it, you can use it because I'll assume you have it memorized. If you, yeah.
Do we always, in this step, just raise it to integral in the second?
Yeah, we always compute this. It's e to the integral of whatever is here.
Okay.
This is the formula.
Except for the 1, right?
Right, because remember the formula, and then so mu of x, good Urash, is this. That's the definition of mu.
Oh, okay.
No, it's good, ask. It's important. It's good. It's worth it. Yeah, this is useful. It's useful in physics too. There was this guy in my office before class, and he was solving a partial differential equation, and he turned it into this stuff, and then he used techniques from this class to solve part of it, not all of it. The rest of it was too hard. To integrate tangent, you can either have it memorized, use your calculator, or you can do it in your head. No. Here's how I do it, and then I'll show you the work, or some of it. Tangent is what over what? Sine over cosine. So if it's sine over cosine, your u is going to be cosine, right? What's the derivative of cosine? Negative sine, right? It's negative. So you're going to get negative 1 over u du. So it's going to be a negative ln, and cosine's on the bottom. I'm going to show you the work now. Don't worry about the plus c, by the way. I don't know if I mentioned that before. Notice I didn't write it here when I integrated. It's gone, but don't worry about the plus c here. So how did I get that? Just like I said I did, but let me just show you. So you can write this as sine over cosine, because ideally you should be able to think through it in your head to enough to where you can memorize it without actually having to memorize it, right? So if you think about it like this, you can let u be cosine. So then du is negative sine. But then you have to get rid of the negative, right? So you do this. I actually don't do all this in my head, but I think, okay, so that's going to become negative du over u du. So that's going to be negative ln u, but u is cosine x plus c. So cosine's on the bottom, its derivative is negative. It's going to be an ln, so you're going to have a negative ln cosine. Yeah?
So basically, we should always try to get an ln in the...
Usually you will get an ln, not always. Sometimes you just get like x, and then it's a little bit weird.
Okay.
That does happen. What if it was cotangent here? What would you get here? If it was cotangent, you would get what? Ln what? Ln sine. And it would be positive, right? Because if sine's on the bottom, its derivative is cosine, and it's positive. So if you have that little bit of forward thinking, you can memorize it. I memorize them like this because I teach Calc 1, right? So I have to like memorize it in a way that I don't forget it. So to me, this is the easiest way to memorize it, right? Because that way I know how to do it too, right? It's not just like, oh, I memorized it for a test. No, I can actually do it. Now you can take this negative and bring it up. So it'll become cosine x to the negative 1, like that, using the power rule. This is actually secant, right? It's the evil secant. Yeah. 1 over cosine is the evil secant function. Secant x. Which is equal to, I'm going to come up here. So mu of x is equal to the absolute value of secant x. I picked this one on purpose. I picked this one for this step here because this step is uncomfortable. It's not, it's hard. This is the hard step. And now we drop the absolute value. So we want it to be positive because that's what we do. So this is true if the secant function is positive. I had a problem in my morning class, and we had 2 minutes left at this point, and I finished it in like 2-3 minutes. I feel really bad for them, but they will live. Yeah, I finished like the whole problem. We have 3 minutes left, and I was like, they were like, oh. This is really tricky. Secant is 1 over what? It's 1 over what? Cosine. So think about the graph of cosine. It looks like this. That's a really bad graph. And this is negative pi over 2, and this is pi over 2. So it's positive here. So cosine is positive here, so secant is positive there. So that will happen whenever x is here. So this is going to be our interval of definition for the problem. It comes from this, right? Because secant is 1 over cosine. The graph of cosine, let me draw cosine. Let me draw this a little bit better. The graph of cosine, it's a wave function, right? It does this. And this is pi over 2. This is negative pi over 2. So it's positive here. It's also positive in other places, but I just picked this one because I think it might be. Is it multiple choice in the homework, Nick?
That one is.
Yeah. And so I think this is one of the choices, right? Yeah. The other choices don't match, so. This is the simplest place that it's positive, right? Again, not on the test, though, right? Not on the test.
What's the value of it being positive exactly?
And let's just drop the absolute value. We have to make a decision. Good question. Yep. Good. Deep. No, good, Anna. Good. All right, so mu of x is equal to secant of x. Good. This is a really good one for the test. Again, on an exam, you would only have to solve the DE, right? Not go through this. Okay. What's the next step? What do we do next? We multiply everything by secant x. Very good. And make sure you multiply this one, right? The one in standard form. I've had people make that mistake. What happens if you make that mistake? You lose some points, right? A couple, actually, but because you didn't make it to the key step. The key step is when, like, this is the key step, right? This is the most important part of the problem. So secant x dy dx plus secant x tan x y. Y what? No, I'm kidding. Y equals secant squared. Too much soda. Be up all night. Huh? I know. Why? I know. Get home like it's 11 o'clock. I don't get home till like 11 because I live really far away. It's like, oh, I'm all wired. It's like, oh. Any questions up to here on this one? This always magically will become something, right? This is that magical step. This marker was like, it was new at the beginning of class, I think. So it's always going to be, what goes here? Secant. You can put the y or the secant first. It doesn't matter, by the way. I'll just put the secant first. And then what goes here? The y.
And is that the y that's always on the second term?
It's a good question. It's always whatever here, whatever you're solving for. So like there's one in the homework, it's like dr d theta, then you would have an r there. That was on the final last semester. That's why I keep thinking of that one. I almost did that one now, but I thought, let me do this one. Now we can check our work here, right? So let's see, the derivative of secant is secant tangent. So the derivative of the first times the second plus the first times the derivative of the second. It checks, it's so beautiful. Derivative of the first times the second plus the first times the derivative of the second. It really, really, really works out nicely, right? And you can always check your work. Sometimes it's a little bit more uncomfortable to check your work. Like the one on the final last semester, like checking the work was a little bit harder, but it was just like this one. What do we do next? What's the next step? What do we do to both? Integrate. Yeah, absolutely. Let's do it. So I'm just going to put int te great. Let's try. I was going to put int, but then I felt not lazy. This is secant x times y equals, when you integrate secant squared, it's kind of uncomfortable. Anyone? Nope.
Absolutely.
Nope. It's really simple. It's just tangent. I know. It's just tangent. I know. It's just tangent. I know, right? It's like, what? Why is it so easy? It is. Right. The derivative of tangent is secant squared, right? I know. It's like, what? It's like secant cubed. That's a beast. Secant cubed is so hard. It has its own Wikipedia page. The integral of secant cubed. Yeah. If you Google it, integral of secant cubed, Wikipedia, and it'll come up. It has its own page. Like the integral has its own entry in Wikipedia. It's ridiculous. Right? I actually learned the integral secant cube in DE. Like, I'd never seen it. All right. I guess we could divide by secant x, but that's going to give us tangent over secant. I don't really want to deal with that. Maybe we can write everything in terms of sine and cosine and then simplify. That might be a little bit easier. I don't know.
Are we just dividing by secant of x again?
Yeah, we just have to find y. But we're going to get tangent over secant, and we have to
So we'll
simplify.
take that answer just divided by secant?
All right, I'll just divide by secant. Okay, but while we write it. So it's going to be tangent of x. I don't know. Well, I guess I would have to, right? Yeah, it would have been easier to do it the cosine way, but yeah. Yeah, like write it as 1 over cosine, sine over cosine, then multiply by cosine.
Oh, okay.
Yeah, it's a cleaner answer. I'm going to do that now. I'm going to clean it up.
Do you leave it like that?
Yeah, I guess you could leave it like this. Yeah. I mean, I can't mark it wrong, right? I mean, can I? I don't think so.
Just for not taking out the cosines, it can't be like.
No, I can't do that. It's just because, like, yeah. Like, oh, that's just wrong. I wouldn't do that. I promise. If I do that, you come see me after the test. Be like, hey, you know, you said you wouldn't do this. I'm like, all right. Sine over cosine. I'm going to rewrite it. I feel bad. Ugh. 1 over cosine. Yuck. Plus, this is 1 over cosine, so it's c times cosine. Wow, this is so complicated. This is just sine, right? Plus c times cosine. My marker cracked. Like, I heard it crack. I was writing. I was like, I heard like a little pop. I'm like, what the heck? I broke it. This problem broke the marker. You could leave it like this. That's fine. Yeah, that's fine. Are there any transient terms in this problem? No, right? Nothing here will go to 0. Just for emphasis, right? Oh, and the interval is here. This is the interval of definition. Say you had x to the 4th plus ln x over x plus c. What are the transient terms? Are there 1, 2? Are there any? What's the transient term here? ln x over x. Very good, because this goes to 0. So that would be the transient term. I just feel bad because none of the examples we did had 1. I was really hoping. I was like, no, not again. You know, like, there needs to be. So you got the transient term? Okay. All right, we should definitely take a break. Take 15 minutes. After the break, we're going to come back. We'll do some calculus 3 stuff, and then we'll do some more DEs. We're going to do exact differential equations, a little bit more sophisticated.